Good evening,
Good
sir.
afternoon. Very good evening, Sankalp. How are you? Hi,
Fine.
Nitish.
Sir, can you give us few questions from the third chapter and the first chapter, sir?
From the third and the first chapter.
The
Yes,
third and
sir.
first are easy.
They are easy. You can, if you have any doubt, then you can ask me there.
So one
In
is
which topic you are? In which topic you are having the doubt?
I don't have a doubt, sir. It's just that if we can practice it, it would be good.
Yes, I will give you more and more questions, but today will be very important session. Actually, we will discuss the atomic models, and we will also discuss about the atomic number, mass number, isotopes, isobars, and the electronic configuration. That's very important.
We were doing protons, sir.
Exactly. So have we completed the discovery of proton?
no sir.
Yes,
Sir, we
sir.
haven't.
Yes sir.
Yes. Yes, I have told you. Okay, okay, we will go ahead. Is this screen visible?
Sir.
Yes sir.
Okay. So let me start here. So we were discussing the discovery of proton. So can you repeat it? Who discovered this proton?
The Goldstein.
Sir, proton was discovered by Goldstein on
Goldstein.
1889, I think.
No, 66.
Yeah, it is 1866, right?
Yes sir.
Goldstein. 18, I just told that there were actually some rays which were coming from anode. They were moving towards the cathode, isn't it?
Yes sir.
Yes,
Yes,
and
sir.
those rays were known as anode rays, or what we call them as anode rays, or they are also known as canal rays, right?
Yes sir.
Yes, sir.
Yes, exactly. And then I'll also told you that canal rays are, we can also call them as positive rays, right?
Yes, sir.
Exactly, positive rays. And then the next is that actually now if we just take here the hydrogen gas, if we just take the hydrogen gas, then actually in these anode rays we will find H positive ions, that is H positive ion. So this H positive is actually known as, this is known as proton. So you will remember that this proton, it has the same charge. So what is the charge of proton? It is same as that of electron, but with positive
So
sign.
1.02 into 10 to the power negative 9.
It is plus 1.602 into 10 to the power
Negative 19.
19, right? This is the charge of proton. Okay, can anybody tell me what is the mass of proton?
So 9.1
We don't know.
11 into 10 to the
No,
power
no,
negative
that's actually the mass of electron.
That is
Proton.
electron.
That is mass of electron.
Oh, I don't know.
Okay, it is 1.674 into 10 to the power minus 27 kg. Got it?
Yes, sir.
So you have to remember this. That is what is the charge and what is similarly the mass of proton and similarly that of electron, right? They're very important. Now I have told this is the mass. This is the mass in kg. Can you just convert it into grams?
Yes, sir.
Yes, sir. It is into 10 raised to the power negative 24.
Negative
It will
20.
be
Yeah,
1
negative 20.
kg. 1 kg is
Okay, negative
1 kg is 1000 gram. That is 10 raised power 3. So it will become minus 24
Sir, 30.
gram.
Oh, 24, 30.
24 dash. You said
Okay,
it correct.
my bad. I told.
Because we know that 1 kg is 1000 gram. 1000 means 10 raised power 3 grams. So when you will just multiply this, so you will get minus 24 grams. So this is correct. Okay. So this is the charge of proton. Now
Sir,
sometimes
for
it's
charge of electron. So for
Mhm.
charge of electron, we should put minus 1.602, right?
Exactly, because electron is negatively charged particle, but proton is positively. Proton is positive, right? You have to remember this.
Yes, sir.
Charge of both electron and proton, it is same. Just the difference is in the sign. Electron has negative charge and proton has positive. Got it? Okay.
Yes, sir.
Now tell me that this is the actual charge of proton. So if I will just say that what is the you can say the relative charge of proton. Can you tell me what is the relative charge of
Excuse
proton?
me, sir.
Yeah, tell
Oh,
me.
sorry. Never mind. Never mind.
Relative charge of proton. Can you tell me what is the relative charge of proton?
One positive one.
Exactly, it will be positive 1 plus 1. Okay, what is the we can say the relative mass of proton?
So
One.
1 gram.
Relative mass of proton is
No,
taken
zero,
as
zero. It's negligible.
no, 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 it is not negligible.
So
Negligible is
it's
that of
one.
electron. Electron has very small mass, but it is taken as 1 unit. It is taken as 1. Okay, got it?
Sir,
Yes, sir.
electron is 10 to the power negative 31, right?
Exactly, negative 31. So that is very, very small, but it is negative 27. So it is little bit higher than the mass of electron. So that's why it is not neglected.
Yes,
It is
sir.
taken as 1. Okay. So this is regarding the
Yes, sir.
proton. So then the neutron was also discovered. So can you tell me who discovered the neutron and in which year?
So,
Lord Rutherford.
Which scientist? Discovery of neutron.
Lord
Rutherford,
Rutherford.
sir.
No, no,
Rutherford.
no, no. Rutherford discovered the nucleus. It is I'm talking of neutron. Neutron was discovered by
Oh,
Chadwick.
oh, James
oh, James
Chadwick.
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 Yeah, James Chadwick. It is the talk of 1932. That is, he discovered this particle late. If you can just remember the equation, I will write it here. What he actually did,
What
he
is
just
U for? Sir?
U is the unit. It is 1 unit. It is not any particular
Okay.
unit. It is a relative unit. Simply,
Okay.
U stands
Whatever
for
it can
unit.
be. Gram,
Yeah,
kilogram.
yeah. It is the relative. It is not the actual unit. So it is U. It is the unit. Simply unit. Okay, now tell me that the discovery of neutron, how he discovered the neutron? He just bombarded this beryllium with the alpha particle. I hope you remember the alpha particle.
Yes,
Alpha
sir.
particle is
Alpha.
No,
simply it is the nucleus of helium. So boron, it's at beryllium,
What
its
is
atomic.
what is alpha particle, sir?
Have we now discussed this alpha particle?
So we
No,
did not,
sir.
sir.
no,
Okay,
sir.
We did not.
no problem. I will tell you. I will tell you. Okay, let me write it here that what is actually the alpha particle. Alpha particle is simply positively charged helium nucleus. You can simply say that alpha particle is okay. I will write it here. Alpha particle. Alpha particle. You can simply write alpha particle just by writing He2 positive. So this He2 positive is known as alpha particle. So can you tell me what is the alpha particle? What is the charge of this alpha particle?
Sir,
Anybody?
Zero.
Uh,
Zero.
No, it has two plus
no,
charge. It has
two
two
plus.
units of charge. It is 2 plus, right? It has 2 units of charge, right?
Sir, but helium is a noble gas, right? Sir, its valency is zero, right?
Its valency is
Exactly.
not zero, da.
Exactly. Say zero. It is a
its
noble gas, but
valency,
I am just talking of
valency is
charge.
zero.
It is here
Sir,
He2 positive. So positive means it has 2 units of charge. I'm just talking of charge, not that of valency. Got it? Okay.
Yes, sir.
Tell me what is the mass of this alpha particle? What is the
Mm,
mass of
U,
helium?
one
Can you
U,
tell me? No, no. What is the mass of helium? Helium, its atomic number is 2. Mass will be 4, right?
four. Mass will be four. Okay.
Exactly. It has 4 units of mass. So you will remember that alpha particle has 2 units of charge and 4 units of mass. Got it? It has two
yes, sir.
units of
Yes, sir.
charge, 4 units. So this is your alpha particle. So that is why I just wrote this alpha particle by just writing this helium, because alpha particle has always 2 units of charge and it has 4 units of mass. Now tell me, when they react, what is the product formed here? Okay, I will write. One,
Um,
one is the that we get the carbon. We get the carbon here. It's a nuclear reaction. And another is we get the neutron. So neutron is represented
Neutron.
by, yeah, exactly. Neutron is represented by this N01. So this is my nuclear reaction. First of all, you will remember here that this is a nuclear reaction.
you already learned that, sir.
Exactly. Okay, so what is the okay? If I will tell you that what is the charge of neutron? Can anybody tell me what is the charge of neutron?
Sir,
Zero, sir.
zero, sir.
Exact,
Zero, it's
exact is
neutral. Sir,
Oh, am I audible?
you are audible, but I think
so.
sir. Okay.
Sir, you're muted, sir. You're muted. Sir, you're muted, sir.
Wait, Ra.
Hello, sir. We can't hear
34.
you.
He's muted. I think
Please,
he's
I'm
speaking to
muted.
someone.
Okay, okay. Yes, sir is muted.
What is this app?
On board record.
Oh. Why are you not coming tomorrow? Oh, you're going to a resort.
Yes.
Why is he not coming tomorrow?
He's going to a
Yes,
resort.
sir.
Yes, sir, we can hear you, sir.
We can hear you.
Okay, so tell me, is this screen visible?
Sir,
Yes, sir.
yeah.
Okay, so shall I move to the next page? Have you
Yes.
noted down this?
Yes, sir.
Yes, sir.
Okay, so I was
Yes,
just
sir.
talking about the what is the charge of this neutron. So neutron is a neutral particle. It has zero charge, right?
Yes, sir.
Yes,
So I
sir.
will write it here
Yes,
that
zero
sir.
colon before, right?
neutron is neutral, so it has zero, right?
Zero colon. No.
So
Is
what
it
about
zero colon?
its mass, sir?
Yes, I will tell you. So it has zero charge, but it has mass. It has mass. So how? What is the mass of neutron? It is same as that of proton, but
This
slightly
plus
greater
and
than that.
minus. Oh.
Sir,
It
it
is
says that the meeting will end in 19 minutes, sir, because the host is not there.
why it is saying like this?
The host is facing a technical issue and is expected to rejoin soon.
Okay,
Otherwise,
wait.
oh, okay.
Sir, I think you should rejoin,
Can you
sir.
guys hear me?
Yeah, we can
Okay.
hear you, but
Go
can't see your video. It has an exclamatory mark above your video.
Hey, this seems he disconnected his
Same
camera.
for me. No, I have my camera on. It's
The camera is on, but it's saying there's a video problem there.
Okay, I will start it again.
Yes.
okay, sir. Bro,
So
Sankalp,
how
why
is
won't you
your
come
day going?
tomorrow?
He's going to a resort.
Yeah, actually, like
He's
my
going to a
dad's
Going to a
friend.
resort.
No, like my like my dad's friend. He came from
Hey, okay,
US
sir,
after
join.
like
Sir, join.
18 years. So
Sir,
that's
can you hear
why
us,
my
sir?
dad
Sir,
is
can you
Yeah,
hear us?
I can
going
hear
out
you.
with him.
So is it now okay?
yes, sir.
Yes,
Yes,
sir.
sir.
So what is the
I
mass
tell
of neutron here?
So 1.67
We couldn't
into
see,
10 to
sir.
the power of
Okay, I will
negative.
write it.
After that, power.
Hey, Kongwell, I'll tell later when we wait for Tarun.
We don't.
Well, he was
Okay,
while he
that's not very
joins.
important.
Okay, now I will write it here. What is the mass of neutron? So the mass of neutron, you will remember it is same, nearly same as that of proton, but slightly greater. So it is actually 1.675 into 10
Sir,
to the
it's like
power
0.01.
10 to the power
Yes,
minus
sir.
27 kg. So what was the mass of proton? Mass of proton was
So
1.674. It is
1.674 into 10 to the power of negative
exactly.
Sir,
0.7.
So
it is higher by 0.001
Hey,
exactly.
kg.
No,
Bongo,
zero
that
point
sir,
zero 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 1%.
So that means
Okay.
we some
hey,
most of the
Bongo,
books write that the
yes, sir.
mass of
Even
proton and the
zero.
mass of neutron it is nearly same. So there is slight difference. So you can remember this. So can you convert it into grams? So it will be 1.675 into 10 to the power minus 24 gram, right?
24. Yes, sir.
Exactly. Okay. So this is your neutron. So neutron is neutral, but it has mass and it has mass nearly same as that of proton, but
Does
it is
it have
slightly
charge, sir?
yes.
Charge.
Charge, it has
They
zero
have no
charge.
charge, sir.
No,
It
no,
has
no,
no
no.
charge.
Zero. It's neutral.
I know that.
Ex-
Neutral.
Exactly.
Oh, relative. So I thought relative charge is what
It
you
is
were
zero.
saying there.
Whether it is charge is relative or actual, it is zero. Okay, now let us see the Thomson's model of atom. Thomson's model of atom. So have you studied this Thomson's
So
model?
it's
No, sir.
so it's a new thing. We are done with discovery of neutron.
Yeah, yeah, we are done with the discovery. Discovery of neutron. It was very easy. That simply you have to remember that Chadwick, he what he did, he just bombarded alpha particle with the beryllium, and he got the neutron there. So neutron is neutral. It is not deflected by any electric or magnetic field. It has just zero charge, but it has mass same as that of proton. So we are done with the neutron. We
Yes,
had
sir.
studied only that, and then we had to move towards the Thomson's model of atom. So J.J. Thomson, we know that he discovered the electron. After that, he also gave the model. He also told that how this electron and proton they are actually inside the atom. So J.J. Thomson,
The
what he told,
arrangement.
yeah, exactly. So it is the talk of 1898. He told that actually atom is a positively charged sphere. So he told that atom is a positively charged sphere in which electrons are embedded. So just like this, it is a positively charged sphere. So according to J.J. Thomson, he told that this atom is positively charged sphere in which electrons are embedded. So let's say this is my electron here. Let's say this is another electron. So electrons are just embedded in this atom. Electrons are negatively charged particles. So this was the model given by J.J. Thomson regarding the structure of atoms. So he told that as many negative charges we are having that of electron, same is the number of protons. So that is why atom as a whole is neutral. So this is very important. So I will write it
Yes,
here
sir.
that what actually he told.
So what about
Uh,
what about neutrons, sir?
neutron was not discovered at that time. I told that neutron was
Oh,
discovered in
oh,
It was in
1930.
okay, yeah,
1932
yeah.
only, no?
Yeah,
You just write
yeah.
down this year. It is 1898. It is the talk of 1898. Newton was not discovered at that time. So what he told that atom is, I will write it here, atom is positively charged sphere, positively charged sphere in which electrons are embedded, in which electrons
So
are
it's
em-
positively charged sphere.
yeah, yeah. According to
So it's
Thomson,
neutral, right, sir?
uh, just to see what first of all J.J. Thomson told. He told it is a positively charged sphere in which electrons are embedded. Electrons are also there, but positive charge is actually due to the protons. Now, what he told that how this atom is neutral, he told that actually there is equal positive and negative charge. So that's why atom as a whole is neutral. Atom as a whole is neutral.
Sir, how can he say that, sir? He just said it's positively and he can't say it's neutral, like, sir.
Why you are just only reading the first part of the sentence? Why you are not reading the complete? He told that atom is positively charged sphere. It is half of the part. The next is in which electrons are embedded. So when electrons are also embedded there, so the whole atom will act as a neutral. You will write it here that whole atom is neutral. Whole atom is neutral because positive charge is balanced by positive charge is
Negative
balanced by
charge.
exactly, it is balanced by negative charge, that is that of electrons.
So it was never positive. The atom was never positively charged, but we are say according to Thomson, it was
Exactly, according to Thomson. See, whenever we are studying any model, you have to first study what that scientist told. So you cannot add your own thing. You have to just study that J.J. Thomson told that atom is positively charged sphere in which electrons are embedded, and he just also gave the example. He told that this model is this atom is like the watermelon. Have you seen the watermelon?
yes, sir.
Yes, sir.
Yes, the reddish part is your positively charged sphere, and the seeds which are inside that they are just like the
Negative.
electrons which are embedded in it. So that's why this is known as watermelon model. So that's why this model is also known as watermelon model, or it is also known as plum pudding model.
So we know this.
Okay, it is also known as raisin pudding model. It has different names. You can call it by any name.
Whoever named this was a foodie.
Is a
It must
pudding.
be. Must
Raisin
be.
pudding
I
model.
learned this. I think by teacher.
Okay, so that is why you have to remember just you are having the reason or the dry kishmish, right? So if we are
Yes,
having
sir.
these inside any dish, they are just embedded. So that is why he told that electrons are also embedded like the seeds which are in the watermelon. So this was the simple model given by the J.J. Thomson. But the limitation of this is that he could not explain the experiment which was done by Rutherford, which is actually known as Rutherford's alpha scattering experiment. Okay, I will write it here. What is the
This
limitation of this model?
neurons existed or something.
Its limitation is that he could not explain he could not explain he could not explain the experiment done by Rutherford. Experiment done by Rutherford. So have you studied that the experiment which was done by Rutherford?
No, sir.
Sir.
Okay, we will see ahead. So just write down this, then we will move to the next
Done,
page.
sir.
Yes,
Yes,
one
sir.
second, sir.
I'm already done.
Yes, sir, you can move.
They couldn't agree.
Okay. So let us see the Rutherford's alpha scattering experiment. This is very important. Rutherford's alpha scattering experiment. So I hope that you now remember what is alpha particle,
Yes,
right?
Yes,
sir.
sir.
So what is alpha particle?
The helium
Sir,
that is present in middle of
Nucleus of
other.
helium atom.
Yeah.
Exactly. It is simply the nucleus of helium atom. That is, you can simply call that alpha particle is your He2 positive, right?
Yes,
Alpha
sir.
particle is He2 positive. This is known as alpha particle. Okay. Now, what the experiment
sir,
was done?
what is
Yes.
that proportion symbol, sir? Is it reaction?
No, no,
Not
no, no. This is alpha. Alpha.
alpha.
This is alpha. This is the symbol
Alpha.
for
Alpha,
alpha.
beta, gamma. Na?
For example, this one is your beta. This symbol is beta.
Gamma is that very, I don't know
That
if it's
horseshoe.
And then there's
Oh, sorry,
gamma,
sorry.
sigma,
This is gamma, right?
mu. Yes,
Exactly. There are
sigma,
different
gamma,
symbols.
mu.
So this is your alpha. This is your alpha. This
Greek
is not the
letters.
yeah, exactly. This is not the proportionality here. It is the alpha. Okay. So Rutherford, what he did, you had to remember this. He just took the alpha particles and then he bombarded on thin foil of gold. So what he did, Rutherford, he took thin foil of gold. So can you tell me how much thin it was? Thin foil of gold.
6.9.
What is the symbol of gold? Can you tell me what is the symbol of gold? It is AU, right?
You
Exactly.
aurum.
Aurum, exactly. It is Latin name is aurum. So it was just 100 nanometer thickness. It was having 100 nanometer thickness.
That's like so
So that,
less. How
yes,
do you
I hope
make
you,
it, sir?
With a hammer.
Like,
yes, we can make
sir,
this.
can this thin foil of gold be like visible to eye? Is it visible to eye?
It's like
This
2D
when
But
it
picture
of
from one
course it
see,
side.
is.
when it is, you know that 1 nanometer is 10 to the power minus 9 meters. So that means it will not be visible to the naked eye. It is just under
So
the
from the side
microscope you
it
can
won't
see.
be visible, from the front it will be visible because it's a 2D
Sir,
object.
we can see the foil of gold, right? Like if we keep it on the
Yeah, like
ground.
if we keep it
You
like
can
from the
exactly
front.
see the foil of gold with the help of microscope, but not with the naked eye if it is having 10 to the power minus 9 meter
So
size.
the thickness is only 100 nanometer. It's like the
So
distance
into
is
hundreds, sir. So that's 10
like
to
a
the
few
power minus
centimeters.
7 meters, no?
Exactly, 10 to the power minus 7 meter. So yeah, this is a little
So that
big.
is equal to
Yes, yes.
10 to the power
That
minus 6 centimeter, no, sir. So it's basically
that is 10 to the power.
Sir,
See, it
it's
is
huge.
minus
basically
7.
one
So
micrometer,
10
sir.
to the
Basically,
power
one
2
micrometer.
centimeter. So that is equal to 10 to the power minus 5 centimeter, right?
It's almost close to a micrometer, right?
Yes, sir.
Yes, exactly. Micrometer. Almost.
Yes,
Okay, now see what actually you had to
Which is
observe
equal
the
to 10 to the
experiment
power
which
minus
was
4.
done by the experiment which was done by actually there was the microscope which was used there for observing the scintillations. Okay, I will tell you here that what he actually did. He just took the alpha particles from the source. What the source was? Can anybody tell me what was the source of alpha particles?
beryllium.
Helium.
No, no, it
Helium
was
Helium.
not.
neutron, helium nucleus.
No, no, no. It was actually the radium. Radium is the source of alpha particles. Radium is a radioactive element, right?
Iridium or
Yes,
radium?
sir.
Yes, radium.
Radium,
So
radium.
Oh, radium.
radium will
It's a
emit various
radioactive
alpha.
element.
Yeah, it is a radioactive element. So it will emit various radiations. So when it is passed through a cylinder,
What does radium do?
remember what is a cylinder?
Radium is the
Yes,
It
sir.
is
Yes, sir.
radium. It is
it is the
radium.
Sir,
So
it's
what
like
is
a
slit?
gap.
Slit is a
Basically,
small
that
cut.
whole thing,
Small,
that
yeah,
whole
it is a
thing.
small hole, or you can say small cut.
We saw in
I split the hole
animals
like
that
that you can say.
protons experiment.
Exactly. Now tell me that
Those give
when
small
they will
gaps
just
into the.
see when these alpha particles will pass through this slit, we will get a straight beam of alpha particles, right?
Yes, sir.
Yes, sir.
This is simply beam of alpha particles. Beam of alpha particles. So alpha particles are just He2 positive, right?
Yes,
Now
sir.
what he observed here that when he just placed here the thin foil of gold, let's say this is my thin foil of gold here. This is the thin foil of gold. Foil of gold. Then what he observed, he just used here the circular zinc sulfide screen. This is the zinc sulfide screen. And what were the observations here? He just observed here that most of the alpha particles they just pass it straight without any deflection. Most of
Yes,
the
sir.
alpha particles they pass it straight without any deflection. And he also noted down that the few alpha particles they got deflected through small angles. And similarly, he also noted down that one alpha particle it was just coming back, it was bouncing back with an angle greater than 90 degree. So this is the experiment which was actually observed by Rutherford. This experiment is known as alpha scattering experiment. Alpha scattering experiment. So these were what were the observations here? First of all, have you noted down this? Have you made the diagram?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir. Like the gap was between what two materials, sir?
Yeah,
That
I
doesn't
will tell.
matter, I think.
I will tell you the various observations and then the various conclusions from this experiment. So first, write down this.
I finished.
Okay, shall I move to the next page?
Second, sir, one
Yes, sir.
second. My internet got cut.
So what is that block behind that radium element, sir?
What is the this? Okay, okay,
Radiation.
yeah. This is a block of lead. It is block of lead.
It is
So why?
How
it
does
is
it
to
help,
not
sir?
like spread the radiation. It won't go
Exactly.
anywhere, no.
See, this is having here the QT. So what is the QT? What it will do? It will just push these radiations only in this direction. So that's why it is there.
Yes,
Yes.
sir.
Here, yeah, cavity in which this radium is actually kept. So when we are having this block of lead, so that means radiations will not go here and there. So they will just pass straight in through this slit, and we will get the straight beam of alpha particles, which will just fall on this thin foil of gold. And then what was the observation here? Rutherford observed that most of the alpha particles they passed straight without any deflection, and the few alpha particles they got deflected through small angles, and one alpha particle among 20,000, one among 20,000 alpha particles bounced back.
Above 90 degrees.
Exactly,
More than
one among 20,000 bounced back. That means it got deflected through an angle greater than 90 degree. Correct? Okay, shall I
this.
move to the next page?
Is it like
So one
exactly
second, sir.
there was only
Yes, sir.
20,000 beams, or is like
One
the
second, sir. One
universe
second.
system
Uh,
is like? Hey, wait, guys. So is it like one day 20,000 beams were sent from the radium, or
No.
like
See. It is just like if you are
there were
having a
infinity number of
it
beams.
is you are having 20,000 alpha particles. Only one among these 20,000 will
so
just come
one
back.
for
It will bounce.
every 20,000 beams went out?
Exactly. If you are having 40,000 alpha particles, that means two alpha particles will bounce back. They will come back.
Yes.
Okay.
Sir,
Okay.
so this radium can emit only 20,000
No,
beams?
no,
Hey,
it is not
Nora.
necessary. I told that only one alpha particle among 20,000 bounced back, but it is not that radium will only emit 20,000. It can emit more than that. Okay,
Like
now let's
one
see.
every 20,000 beams.
Yeah, exactly. One among every
Just a
20,000.
probability.
So let's see the various observations of this experiment. Observation. So what were the observations? Observation first was that most of the alpha particles passed straight, right? Most of the alpha particles passed straight without any deflection. Most of the alpha particles passed straight without any deflection, correct?
Yes, sir.
Without any deflection. Then what he observed, the next thing he observed that few alpha particles they got deflected through small angles. Alpha particles got deflected. Few alpha particles got deflected through small angles, right?
Yes, sir.
Through small angles. Small angle means less than 90 degree, right? That is acute angle.
Yes,
A
sir.
very few alpha particle. And next thing what he observed was that a few alpha particles, that is actually
Yeah.
one among 20,000, right?
Yes, sir.
Okay, I will write it here that a very few alpha particles, that is one among 20,000 bounced back. Got it? So these were the three very important observations. Then what were the conclusions from this experiment? Can anybody tell me?
So he
Sir,
proved that
alpha particles can pass through metals.
Exactly. So that means actually, see, most of the alpha particles they pass it straight. So that indicates that there is empty space inside the atom. Got it?
so it also indicates some like one of every
Sir, how does it indicate that?
so like
Okay, I
it
will
also
tell you.
indicates some
So
beings like
let you write the various conclusions from this experiment. What were the conclusions? So
so it also
the first conclusion was that, okay, I will write, you just listen keenly. The first conclusion what he got, that is the Rutherford, he got that most of the space in an atom is empty. Most of the space in an atom is empty. So that is why most of the alpha particles they are passing straight, because there isn't any such particle which will just stop the speed of these alpha particles. So most of the space in an atom is empty. You have to remember this. This was the observation which was done by Rutherford. So most of the space in an atom is empty. Next, he concluded that there is a positively charged particle. There is a small positively charged particle. There is a small positively charged particle inside the atom.
Sir, empty means is there like only vacuum?
Empty means, yeah, vacant. You can just write vacant, empty space, vacant. That means there isn't any particle there. So there is, it doesn't mean it is completely vacuum. It is simply empty. Just if there is a room
mostly empty space.
which is not having any person there, so that is empty room. But there is still gas. But here empty doesn't mean it is vacuum completely. You have to remember that it is empty. So that means there isn't such any big
Mostly
particle which will stop the motion of these alpha particles. So next conclusion was that there is a very small positively charged particle inside the atom known as nucleus. So that is why you have to remember that nucleus was discovered by Rutherford. So first we have told that electron was discovered by J.J. Thomson. New proton was discovered by Goldstein. Neutron was discovered by Chadwick. Now there is the nucleus. So nucleus is discovered by the Rutherford. So have you got it? Nucleus was discovered by the Rutherford. This is the very important. You have to note down this. So next conclusion was that this nucleus is very small and is heavy. So you will write it here that nucleus is very small and heavy. Heavy means that is whole mass is concentrated in it. That is whole mass of atom is concentrated in it.
Sir,
heavy in the sense
basically
heavier than the other two
it has the most mass in the it consumes the most mass in the atom.
Exactly.
like
Why can anybody tell me that why it is heavy?
Sir,
What particle
because
is
it
it?
it is
has
charged is
nucleus,
neutral.
it's
That-
neutrons.
See, actually it has proton inside it as well as the neutron. So that is why whole mass is inside this. So whole mass of an atom is concentrated in it. You have to remember that this nucleus it was discovered by Rutherford. So these were the three very important conclusions. So the first conclusion was that most of the space in an atom is empty or vacant. There is small positively charged particle inside the atom known as nucleus. Now note down this that it is positively charged. This is very important. I will explain it why it is positively charged. So known as nucleus, and this nucleus is very small. That is why it is small, because we have noted down that only few alpha particles, that is one among 20,000, bounced back, right?
Yes, sir.
Yes.
Yes, sir.
So
Exactly.
those are like nucleus atom electrons. No, sorry,
electron
subatomic
electron
particles in the nucleus.
Electrons are not an
have you noted down this? I will draw the structure on the next page.
Yes,
yes,
sir.
sir.
Done, sir.
Electrons are in, sir.
Okay,
1 second, sir.
write down.
You send me the physics record.
Physics or bio?
Physics, sir. Why do I need bio?
You asked me bio.
Hey, send me.
Shall I move to the next page?
Yes, sir.
Okay, see now, what was the structure told by this Rutherford? So according to Rutherford, there is a positively charged particle inside the atom, and then actually electrons are just revolving around this positively charged particle. So electrons are outside. Got it? Outside the
Yes, sir.
nucleus.
Yes.
Yes. So this is the structure of an atom. So you will note down this, that this positively charged particle which is in the center, that is your nucleus, and the
Nucleus is that small compared to an atom.
exactly, nucleus is very small. That's why I have written that it is very small. And these electrons, they are just revolving around the nucleus. So this is your electron here. So electrons are outside
There is
the,
one orbit, sir.
exactly, this is actually known as the orbit. So this is known as orbit.
Oh, there's only one orbit, so if like
I
has
I
four
mean,
orbits,
There
will
is
be
only one electron. Is there
No,
only one
if
orbit?
we just talk of hydrogen atom, then there is only one orbit, because hydrogen has only one electron in it, right?
yes, sir.
yes, sir.
Okay, now tell me what is inside the nucleus. Inside the nucleus, which particles are there?
Proton and neutron.
Sir, proton and neutron.
Exactly, there
Proton
are
and neutron.
protons. There are protons inside the nucleus, and there are the neutrons. So, can anybody tell me these protons and neutrons? They are together known as?
Nuclear.
Nucleus.
No, they are
Subnucleus particles.
no. They are known as
Nucleated.
Sir,
nucleons. They are known as nucleons. This
okay.
is very important. I hope you will remember this. They are known as nucleons.
Yes, sir.
This is very important, that the protons and neutrons, they are together known as nucleons. This will be asked in the exam. This is very important, nucleons. So protons and neutrons, they are together known as nucleons. Okay. Now, what was the
Sir,
model given?
is there any other particle other than these two in the nucleus, sir?
Neutron.
Yes, actually, there are particles also. For example, if I just talk of this proton, this is further made up of quarks. There are very small particles known as
What? Gluon. Gluon.
quarks. And similarly, there are antiparticles are also inside the nucleus. But you have not studied those antiparticles are there. There are mesons also. There are various particles.
So we can say that semi-atomic part, what is the thing called? Protons, neutrons, and electrons. They're
Subatomic.
called
They are known as subatomic.
subatomic. Yeah,
Yeah,
subatomic particles. Sir, so we can say subatomic particles are not the smallest particle.
exactly. There are also the these are your fundamental particles. Quarks are the fundamental particles. So you can call them as fundamental particles, but the subatomic particles are the man, they are the electron, proton, and the neutron. So these you can call as fundamental particles. Fundamental particles. But you have not studied these. They are very small particles. You have to just focus on the electron, proton, and neutron. Questions will be asked from that portion only. So now tell me that after this experiment, Rutherford gave the model. So that is known as Rutherford's model of atom, right?
Yes, sir.
Rutherford's model of atom. So can you tell me what he told in this model, Rutherford's model of atom? So he told that atom consists of two particles. One is the nucleus, another is the outer nuclear part that actually contains electrons in it. Okay, I will write it here. So atom consists of nucleus and extra nuclear part in which electrons revolve around the nucleus, in which electrons revolve in circular paths orbits known as orbits. Got it? So this was the main point what he told in his model. That is the Rutherford's model of atom. So Rutherford's model, it was given in which year? Can anybody tell me? It was given in 1911.
The 1968.
No, 1911. 1911.
Oh.
Okay. So what he told in his model that electrons, they revolve around the nucleus uh, in circular paths known as orbits. Now, what was
Sir,
the next point?
when were new? Nothing, sir.
Sir, continue.
Sir, how can Rutherford state there is something called as neutron in 1911 when neutron was discovered on
Nucleus.
1932, sir?
Nucleus.
Yeah, he said
Okay,
nucleus is
okay,
made up
okay,
of
okay.
neutrons and protons.
Just wait. I will clear it. He just told that there is a positively charged particle known as nucleus. He was not knowing that there are neutrons inside it. I have just told you that inside the nucleus there are protons as well as neutrons. Neutrons were discovered late in 1932. That is correct. He didn't told that there are neutrons inside the nucleus. He just told there is a positively charged particle known as nucleus. It is I who told that there are protons and neutrons known as nucleons. You have to actually remember this term. That is why I told this thing. Got it?
Yes, sir. Yes, sir.
Okay. What is the next point? Next point, he told that electrons and the nucleus, they are held together by electrostatic force of attraction. Electrons and nucleus are held together. That means they are attracted with each other, are held together by electrostatic force of attraction, right?
Yes, sir.
Electrostatic force of attraction. So
Finally,
this
the
was,
point on.
yeah, this was the next point what he told in his model. Now, this Rutherford's model of atom, it is also known as planetary model of atom. So can you tell me why it is known as planetary model of atom?
So because like the solar
Because
It's
the
system, sir,
arrangement of
things
the
revolve
like
around
a
the
electrons and
solar
center.
system,
nucleus
sir.
is in like a so
Like all our
is in
planets
like a
orbit around the sun. It's the same way
Exactly,
yes,
that
sir.
exactly.
electrons orbit around the nucleus.
So it is,
This is
he
the
just
inside the star.
compared it with the solar system. He just told that if this is the sun in the center, then the planets are just revolving around this. So he told that sun is just like the nucleus, and the planets which are actually revolving around this sun, they are just your the electrons. So that is why he just
Sir,
compared it. Okay,
sir,
tell me.
the mass of the nucleus is more than the mass of electrons. Is that why the electrons are revolving around the nucleus? Because the mass of the nucleus is more?
Yes,
Then
nucleus has more mass because there are also the protons and neutrons inside it. So that's why it is
that's
stationary.
not
It is
a good
there.
that's not a good
Yes,
Electrons are
sir.
actually the charged particles. They are negatively charged. They have very small mass. So that's why they are actually revolving. They are actually having wave nature, wave, which we will study, which you will actually study in the higher classes. Wave is always delocalized. That is always in motion. So that's why electrons are in motion.
answer.
Yes,
You
sir.
will study that in higher
Something to
classes. You
orbit
have to
around
just,
some.
yeah, you have to just note down this. That is what he actually told in his model. So got it? Is there any
Yes.
doubt here?
Yes.
Okay.
Yes, sir.
Have you noted down? Shall I move to the next page?
Yes, sir.
Seconds, sir.
Yes, sir.
Yeah, okay. Sir, something to orbit around something, its mass should be heavy
Okay, so
enough
you can
to
move.
bend with the space and
Okay, now
time.
tell me what is atomic number? What is atomic number? This is very important.
The,
So can you go to the previous slide for a second? I'll take a
the,
screenshot along.
Which
the
one?
order in
Fourth
which
one.
periodic table is
The
written.
previous slides. I'll just take a screenshot
Okay,
of the
just
last part.
So it's the order in which periodic table is written.
but what is
Yes,
the
sir.
atomic number? How can you define this? What is atomic number?
Um,
Mm.
Atomic number is
So atomic
represented by
number is the
the,
number of protons that is equal to the number of electrons.
exactly, it is the number of protons in an atom, right? So this is
Yes,
very
sir.
important. You have to remember this, that atomic number is the number of protons in an atom. And you have to remember also that in neutral atom, if atom is neutral, right? Then the number of protons, it is always equal to the number of
Yes.
electrons. So number of protons, it is always equal to the number of electrons, right?
Yes, sir.
So if I will tell you that if I'm having hydrogen, so what is the atomic number of hydrogen? It is 1, right?
One, sir.
One, sir.
So how many electrons are there? There,
one electron and one
exactly.
proton.
And there will be one proton, exactly. Okay, so if I'm writing like helium, so its atomic number is 2, so that means it has 2 protons and it has 2 new
Two
electrons, right?
Yes, sir.
If I will write neon, neon is having atomic number 10, so it has 10 protons,
Ten
it
proton
has
and ten
also 10 electrons. Got it?
Yes, sir.
Okay. Then tell
Yes,
me
sir.
what is mass number? What is mass number?
It's the mass of an atom.
So it's the number.
Sir,
So
it's
mass of
the
the nucleus.
yeah, mass of the
Nucleus. Oh
nucleus.
yeah.
It is the sum of number of
The
protons and
total number
neutrons.
of protons and total number of neutrons.
Okay, why not electrons?
The
Sir,
same thing
So
because
as
because their mass is very negligible, it's very
Very
less
good, very good.
when
Because
compared.
electron mass is very, very small, and I have told you that that is neglected. That is taken as zero. The average mass of electron is taken as zero. Correct?
yes,
Yeah.
sir.
Yes, sir.
So that means, for example, if there are let's say two protons and there are two neutrons, what will be the mass number? It will be four, right? For example, helium. Helium, its atomic number is two, mass number is four, right?
Yes, sir.
Okay, I will write it
Yes.
here that this is actually this two represents what? This two represents your it is your Z, that is the atomic number, right? And this four here actually represents the mass number, so this is your E. Got it?
Yeah.
Okay, so tell me that if you have to calculate the number of neutrons, how you will calculate number of neutrons?
So just subtract the mass number by proton.
With A
Mass,
minus Z.
mass
You will just write
yes,
A minus Z. A minus Z. A is the mass
oh,
number minus Z is the atomic number.
it's the same
For
thing.
yes, sir.
example, for example, here in case of helium, E is 4 and Z is 2. So 4 minus 2, that is 2. So that means there are two neutrons in this helium. Got it?
Yes, sir.
Yes, sir. We
Now
learned
tell
this
me
in
what
eighth.
have you got it?
Yes, sir.
Yes, sir.
Now, question will be asked in the exam. What is the difference between mass number and the atomic mass? Is there any difference or is it same?
No, sir.
There, so there is
The
difference, sir. There is difference.
So
What is
there's
the
a
Yeah,
difference?
mass
slight difference
number is the
because of
mass of
the
the nucleus.
electron mass.
Atomic
yeah, electron mass.
mass
No,
number,
no, no.
atomic mass is the
Electron
mass of
mass
the
is
entire
always
atom.
neglected. That is taken as zero, always. Atomic
Yes,
mass,
sir.
it can
So there's
be,
no
atomic
difference.
mass, there is the difference. Atomic mass can be fractional. It can be fractional, but mass number is always whole number.
Yes.
This is very important that mass number is always whole number. It is always whole number, but this atomic mass, it can be fractional. Can you give me the example of fractional atomic mass? For example, what is the mass of chlorine?
35.5.
Exactly. So it is fractional. But if I will tell you what are the isotopes of chlorine, chlorine is 1735. So another is chlorine 1737. So this 35 and 37, it is the mass number, but this 35.5, it is the atomic mass. Got it now?
So what is the
Yes, sir.
mass number, sir?
Mass number is the sum of number of protons and the number of neutrons. It's always a whole
So,
number.
so you're telling the difference between mass number and atomic mass, right?
Exactly. The difference which you have to remember here is that mass number is always a whole number, but atomic mass can also be fractional. For example, okay, tell me what is the atomic number of hydrogen and what is the mass number?
So
Atomic
atomic
Just
number
number
is
is
the
one.
one.
atomic number is
Mass
one.
number is also
Mass
one.
number is
Mass
also one.
number is also one, right? Right.
Yes.
But if I write the atomic mass of hydrogen, it is actually 1.008. So it is not a whole number, it is fractional here. Got it?
Sir, if we say like that, everything has a fractional rate.
Exactly. Everything has a fractional atomic mass. It is actually due to the isotopes. For example, chlorine is having two isotopes, 35 and 37. So that is why when you just take the average will come out to be 35.5. Got it?
Yes, sir.
Exactly. So remember this, the difference between the mass number and the atomic mass.
Yes, sir.
Shall I move to the next page?
Yes, sir.
Okay. So I hope that now you can calculate the number of electrons, protons, and neutrons. For example, if it is my phosphorus, atomic number 15, mass number is 31. Can you tell me how many electrons are there, protons are there, and neutrons are there?
And neutrons
Sir,
are 16,
number of
sir. Protons are 15. Electrons is 15.
So
Stop
protons are
spamming on
15,
the answer.
electrons are 15, and neutrons
Neutrons are 16. 16.
exactly 16. Very good. So
Raise
if
your
I just
hand
write
first.
S2 negative, S2 negative, atomic number is 16, sulfur. Tell me the number of electrons, protons, and neutrons.
2 raised to
Yes,
So,
9.
sir. The number of electrons equals to
16. Proton is also 16. Neutron is
Proton,
um
80.
electron is also 16.
no, electron will be 18.
what?
Oh, sir. Wait,
I
what?
thought
So number of
proton
oh,
was
it's not a neutral atom.
Exactly, it's not neutral. When it is neutral, then it will be SAM. For example, if it is sulfur 1632, so here the number of
Oh,
electron will
okay.
be 16, proton will be also 16 here, neutron will be also 16.
Sir, how can, like, oh, okay.
Got it? Okay, I will
They
tell you.
asked
Yes.
this in the exam. How can we
For
identify
So we
the
example,
understand, sir.
okay, if you don't understand, I will give you the example. Fluorine, its atomic number is
I
9.
sir, I get it.
Proton, it has 9 electron, right? But if it gains one more electron, it will become F negative, that is fluoride ion. So here it will have now 9 protons, but the electrons will be 10. Got it?
Yes, sir.
Exactly. Okay, now can you then tell
Yes.
me that
So it's
that
not
how?
neutral.
Yes, it is not neutral. Exactly. When a number of proton and number of electron they are different, so it means it is not neutral, right? Got
Yes,
it?
sir.
yes, sir.
Yes,
For
Yes.
ex-
sir.
okay, can you tell me how many electron, proton, and neutrons are in this any positive?
Um, so there is
Sodium, it has atomic number 11 and mass is 23.
Yes, sir. I'll tell this. So
Sir,
number of protons equals 11. Number of protons equals the number of electrons equals 11.
No, electron will not be
And
here
number of
11.
neutrons.
It is any positive. It has lost one electron. So there are only 10
Oh, it's 10.
electrons.
10, 10.
10. Now, yeah.
Exactly.
Neutron
And
equals
12.
11, sir. 12. My bad. 12.
Number of neutron, it is always equal to A minus Z, right? A minus Z. A is here 23 and Z is 11. That is 12.
Yes, sir.
Got
12.
it? Exactly.
Sir,
So
so
I hope that
basically only
So
noble
this is
gases are
also like
neutral atoms.
a sodium. So this atom is carrying a positive charge.
exactly is Na is carrying here the positive charge. That's why it is here. Electron will be here 10. If it was neutral, at that time you will write that it has 11 protons. It will have 11 electrons, right? Here and 12
yes, sir.
neutrons. Okay, now tell me if I'm
Yes,
just taking this, let's say I'm taking aluminum, Al3 positive, Al plus
Al3
3.
positive.
Three
Yeah,
positive.
exactly. How many electrons, protons, and
Oh,
neutrons will be there?
So you didn't give the
So
atomic
you
number.
didn't give the you didn't give the
Atomic number,
atomic
sir.
number. Atomic
Okay,
number, sir.
you should actually know the atomic number up to the calcium.
yes,
Atomic
sir.
number is
He
30.
knows
Oh yeah. 30, okay.
1327.
So electron
Exactly.
is electron is
Sir,
12.
electron
No,
is 10, sir.
proton is
Proton is
no.
13.
Electron is
Neutron is
16.
Yeah, electron
14,
is.
sir.
Electron is
Electron
Yes,
10,
that's
is
correct.
electron is
13.
Electron
10,
is
proton
10.
is 13,
13,
neutron
Proton
is 14.
14.
Exactly. Correct.
neutron
Neutron
is
is
14.
14.
Exactly.
L Atish.
I have to say it.
Got it now?
You took some time. I said it
Eh,
immediately.
Okay, shall I move to the next page?
Yes,
Yes,
sir.
sir.
Okay, now tell me, for example, if question is given to you that it is your He4 and it is your He5, what is the difference between the two?
yeah, their mass number is different.
Exactly, their mass number is different. So can you tell me in each case what will be the number of electron, proton, and neutrons?
They're a bit different.
Sir, helium
helium electron will
remove
be
your
two,
hand,
Sir,
Ra.
helium
proton
to
will be
sir,
two,
helium mass number
neutron
5,
will be
electron will be 1. Electron, helium to the mass number
Atomic number
4.
is 2, sir. For helium, atomic number is
Exactly,
2.
exactly. For helium, atomic number is 2, so there will be 2
2
electrons. There will
electrons
be 2
as well as 2
protons
protons.
Two protons
and
and
Same
two
neutrons.
for the other side
neutrons.
also. Only neutron will
No,
differ.
no, no.
Here 3,
No, no, no.
only
Electron will
neutron will
be, sir,
differ.
electron will be
no,
1, sir.
electron won't
Electron
differ,
will be
da.
1, sir.
Electrons will
Yeah,
not differ here. It is the mass number different. It
atomic
is not
number is
any
The
charge.
same, right?
Exactly.
the neutral
Is it now
light, the
clear?
isotone,
Yes, sir.
Have you got it now?
Yes, sir.
isotone, sir.
Is there any doubt? Anybody?
No, sir.
So it's
No, sir.
isotopes only, sir.
Yes, number of neutrons is given by A minus Z. So A is here 5 and Z will be same. Atomic number is 2 here and also here the 2. So that is 3. 5 minus 2, that is 3. Got it?
Yes, sir.
That is this one. So can anybody, okay, that is actually how we can tell this one. Then actually we have to move towards the Bohr's model and the electronic configuration, I think, which we will study in the next class. I think time has
Yes.
gone, right?
Yes, yes sir. It's 6:48.
Yes, sir. Thank you, sir.
Okay.
Bye, sir.
Most welcome. Have a nice day ahead.
So bye, sir.
I just said it before. Thank you, sir. Bye, sir.
Most welcome. Bye.